Introduction to abstract classes in Java. So welcome everyone. We are going to look at the fundamental concept in Java programming. It is abstract class, and this concept is really important for understanding object-oriented programming and inheritance. Just to give you a brief overview on inheritance, inheritance allows us to extend the functionality of existing classes in a hierarchical manner. Abstract classes specifically provide a blueprint for other classes, helping us to achieve software design flexibility and robustness. What is an abstract class? So an abstract class in Java is a class that cannot be instantiated on its own and must be extended by other classes before it can be used. Unlike regular classes, abstract classes can contain abstract methods which do not specify an implementation. These methods instead must be implemented by any subclass that derives from the abstract class. So this design forces consistency and specific behavior across all subclasses. So here's an example of an abstract class vehicle with one abstract method called start engine and one concrete method called stop engine. A little bit more on abstract methods. So abstract methods are methods in an abstract class that only have a declaration and no implementation body. They are declared with the abstract keyword and must be implemented by any subclass. Uh, to give you an example, say you have an abstract method void draw in a class shape, and it requires that any class that extends shape provides specific implementation details for how it should be drawn. And this ensures that each shape drawn by application follows to a standard protocol, yet can behave differently depending on the specific shape type. Another example you can see is animal class, and this animal class has abstract method make sound so that each animal that implements that is subclass of animal will implement this make sound differently to emit a specific sound. Creating an abstract class. So we can look at how we can create an abstract class. One example is shape. The abstract class shape, you can see, can include both an abstract method called draw and a concrete method move to that accepts X and Y. So as we learned, draw must be implemented by subclasses. Move to will provide a common implementation that can move any shape to a specific location. This demonstrates how abstract classes can mix complete and incomplete functionalities to provide a more structured approach to software design. Extending abstract classes. So when a class extends an abstract class, it inherits all of its methods, but it must provide implementations for all abstract methods. So we can see here example shows the circle class extending shape. You can see how circle provides the specific implementation of the draw method. So this requirement ensures that any object of type circle knows exactly how to draw itself, fulfilling the contract established by its superclass shape. Now, let's look at practical example. Let's think of a simple graphics program where we have several different types of shapes, circle, squares, and triangle. And each of these shapes extends our abstract class shape and implements the draw method differently to display itself on the screen. So this structure allows a program to handle a different shape in a uniform manner, and this simplifies code maintenance and extension. Here's an example of square and triangle extending the shape class, and we can see that each has its own implementation of the draw method. Benefits and limitations. So using abstract classes offers significant benefits, including code reusability and enforcement of a consistent interface in subclasses. However, there are limitations. So for example, abstract classes on its own cannot be instantiated directly. This means you cannot create an object of an abstract class without inheriting it in a subclass. This can sometimes complicate design and may lead to deeper inheritance hierarchies than you were initially expecting. Abstract classes versus interfaces. These are two concepts that a lot of students can be confused with, because abstract classes and interfaces are often mentioned together as they both facilitate abstraction. However, they serve different purposes. Abstract classes can hold state and have both abstract and full methods. Interfaces, until Java 8, could only contain method declarations. But with the introduction of default methods in interface in Java 8, I'll say the line between the two has blurred a little bit, but each still has its unique use case based on the needs of your application. Here is an example that shows how an abstract class graphic object implements an interface drawable and includes state, which is X and Y. So this shows the difference between abstract classes and interfaces. Conclusion. So abstract classes are a powerful part of Java. It allows us to write more maintainable and scalable code. I encourage you to start using abstract classes and see how it can help organize and manage code bases. Thank you, everyone.